for this. What is magnetic flux? It's a simple thing. Yes. See, the Faraday only, he discovered the relationship between B and A. What is B and what is A? See, flux is the dot product of B and A. What is B? Yes, magnetic field strength. What is A? A is the area vector. When you will remove this dot, there will be a BA cos theta. And what is this theta? Theta is the angle between A and B. Theta will be the angle between A and B. Okay. Now my question is, if you want maximum flux, so what should be the area between B? What should be the angle between A and B? I repeat the question. If you want the maximum flux, what should be the angle between A and B? Anyone? Kanika, Mamta, anyone? Yes, the question is, if you want maximum flux, what will be the angle between A and B? See, if you want this maximum, that means you will take cos theta maximum. And when cos theta will be maximum? Cos theta will be maximum at cos 90. Cos 90 is 1. So at 90 degree, when angle between B and A will be 90 degree, when angle between B and A will be 90 degree, that though what will be the value of flux? If this is 90, this is 1. If cos theta is cos 90, the value will be 1. So your phi will be equal to what? That will be equal to BA. And similarly, if you have many such surfaces, then you will use this formula. Sum of BA. Sum of BA. Okay? Yes. So what is the unit? The unit is Weber. And the unit is Weber or Tesla meter square. Weber or Tesla meter square. So what is the unit of flux? Flux is Weber or Tesla meter square. Also remember one thing, that your magnetic flux is a scalar quantity. Okay. So basically, what is magnetic flux? Magnetic flux is the product of magnetic field strength and the area. If you remove that dot sign, what will come? There will be a BA cos theta. Okay, then if we have many surfaces, what will be the flux? Flux will be sum of BdA. What will be the unit? Unit will be Weber or Tesla meter square. Okay, then this is a scalar quantity or vector quantity? It is a scalar quantity. It is a scalar quantity. Let's see some numerical based on these two topics which we have studied. Yes, first question. Which among the following affect the deflection in the galvanometer? Options are A, area of the coil, B, current passing through the coil, C, speed with which the bar magnet is pulled toward or away from the coil, D, resistance offered for current flow. Resistance offered for current flow. Anyone? The question is, I repeat the question. The question is, which among the following affect the deflection in the galvanometer? Affect the deflection in the galvanometer. Options are area of the coil, current passing through the coil, speed with which the bar magnet is pulled or is pulled away or toward from the coil. The D, resistance offered for current flow. What will be the right one? The right one will be option C. C, area not possible, current also not possible, resistance also not possible. If you see what we have to check, we have to check the deflection. If you if you if you push the magnet with high speed, there will be a high speed deflection. If slowly, if you remove that magnet, there will be a slow deflection. Okay, so it depends on the speed. Yes, it depends on the speed. The next one. Yes, the next question is, it's a structural question and it can be asked. This type of question are the very important question in your examination. Okay, I will solve you this question. The question is, the magnetic flux linked with the coil is changing with time t in accordance to 6t square minus 5t plus 1, where phi is in Weber. At time t is equal to 0.5 second, the induced current in the coil is how much? We have to find, and resistance is given. First, we will write what we have. We have flux. What is flux? Phi. What is phi? Phi is 6t square minus 5t plus 1. Then we have time. What is time? Time is 0.5 seconds. Then we have resistance. What is resistance? Resistance is 10 ohm. And then current. We have to find the current. Okay, we have to find the current. How? See, this is changing. Means at time 1 second there will be the phi will be something else. At 2 seconds it will be something else. So if you will substitute the value of t, you will get it at that particular time. What is the value of phi? You will come to know from that. Okay, what you want to find? You want to find the current. Now, please let me know what is the formula for current. As per Ohm's law, V is equal to IR. But in this chapter, in place of V, we are using E. That means E is equal to IR. Okay. That means I will be equal to E upon R. Check, 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 check. I is equal to E upon R. We have R. We don't have E, but we have the formula for E. What is E? What is E? E is d phi by dt, rate of change of flux. That means d by dt of phi. What is phi? Phi is 6t square minus 5t plus 1. So this will be equal to 6 constant, it will come out. T square will be nothing but 2t minus this will be only 5. So this will be equal to what? 6 2s are 12t minus 5. Okay. E is 12t minus 5. But we have to find E. We have to find E. I'm solving here. At time what? At time t is equal to 5. So I will write t at time 0.5 seconds. So this will be equal to, just write it there. Yeah. At time what? Time will be 0.5 seconds. So here we have 12 into 0.5 minus 5. 12 into 0.5 means 6. 6 minus 5 will be what? It will be 1. So your E will be equal to what? Your E will be equal to 1 volt, not ohm, 1 volt. You got the value of V. You have the value of R resistance. You can easily get the value of I. What will be the value of I? I will be equal to, I'm writing once more. Yes, what will be I? We have I is equal to E upon R. What is E? 1 volt. What is resistance? Resistance is 10 ohm. So 1 upon 10 will be what? This will be equal to 0.1 in terms of what? In terms of not volt, ampere. Why ampere? Current. Okay, current. So current will be in terms of what? It will be in terms of ampere. Once more, see what approach we have. This type of question are marked as very important question. Huh? You'll get lots of question like this in our portal. Okay, solve this type of question. It can be asked in your MCQ, in your structural question, and there are many chances of asking such type of question. They can change the value, they can change the equation, but the concept will be same. Either they will ask just to solve to find this E, electromotive force, or they will ask you to find current. Okay, yes. So what the approach was? We have Ohm's law. V is equal to IR. In place of V, we are using E. That means E is equal to IR. So I will be equal to what? Your I will be equal to E upon R. And what is E? E is equal to d phi by dt. E is equal to the d phi by dt. So you will have to differentiate this thing. You will have to differentiate this thing and you will get the value. You will get the value as 12t minus 5. Then at time 0.5 second, na, you will write. So you will get the value as 1 volt. So your current will be equal to what? It will be equal to E upon R. What is E? 1. What is R? 10. Okay? Yes. The next one. Next one, next one, next one. Yes. Pick out the SI unit for magnetic flux. Anyone? The questions are, pick out the SI unit for magnetic flux. Options are ampere, Tesla meter, Weber, or Maxwell. Ampere will not be there. Why not there? Ampere is a unit for current. Even Maxwell will not be there. What about Tesla meter? Nah. Why not? Because Tesla meter square is Weber. Okay. So what is the unit of magnetic flux? Magnetic flux unit is Weber. Even not Tesla meter, that was Tesla meter square. Here there is Tesla meter. If this would be a Tesla meter square, we would have considered this option, but here we don't have square, so you will not consider this thing.